This is a demonstration of pressure differences. What I'm going to do is I'm going to take this jug, I'm going to pour some water into what is currently an empty can. So not very much water, maybe just 20 milliliters or so. And what I'm going to do is I'm going to heat that water up over this burner. So let me fire up my Meeker burner. And I'm going to use tongs because holding this with my bare hand would be unwise. So as I'm heating this up over the burner, what's going to happen is we're going to heat that water in there up until it starts to boil. And as that water boils, the water vapor, the boiled water, the steam, the water vapor is actually going to be forcing the air out of the can. As I feel it boiling, what I'll do, since we're waiting for it to boil, what I'll do when I feel it start to boil is I'm going to flip this over into our big beaker of cool water. What's going to happen is as the water cools, the water vapor will condense inside of the can. As that water vapor condenses, it takes up about 1,000 times less space than it does when it's vapor. And because it's condensing and it's taking up so much less space, it's creating a low pressure zone inside the can. Low pressure inside the can and high atmospheric pressure outside the can. The atmospheric pressure is going to try to push and equalize those two different pressures. But it'll have to push on the water that's in the beaker and try to push the water into the can. Since water can't flow that quickly into the can to equalize those pressures, we're going to see the can actually get crushed under the pressure just from the atmosphere, the pressure that you and I live under every single day. So as we heat this up, I can feel it starting to boil and we see some steam coming out of the top. I'm going to count it down. 3, 2, 1. 3, 2, 1. And if you look at the amount of water that comes out, it's more than I poured in because that atmospheric pressure pushed more water into the can before it got crushed.